synthetic base stocks. In the world of base stocks for oil, we go all the way from just really trashy petroleum oil that's group 1 to group 2, which I think they finally decided to refine the big chunks out of the oil so that it would look better. And then we go from group 2 up to the first stages of what we call group 2 plus, which is a beginning of hydrocracking oil. Now, I want to explain hydrocracking for just a minute because it's so prevalent in the marketplace, and to understand what it is. When we refine petroleum oil, you're going to get to a finishing stage, and in most cases that oil then would be packaged and it would be shipped. That would be the finished product. It would be cleaned up pretty well, and the oil would be cut to a certain weight, the best they can for standard petroleum. Well, when we go to hydrocracked oil, what really happens in general, because it's a little more complicated, but in general, the oil is basically heated to a high temperature relative to, say, 1,000 degrees at a pressure of around 3,000 pounds, somewhere in that range, depends upon the level of hydrotreating going on. At that point, the oil has gone from being a liquid to being a gas. And as a gas, it can be separated by molecular weight and taken off in what's called cuts of molecular weight. So that allows you then to take out the good hydrocarbons for lubrication, collect those, and to collect all of the impurities in the oil that came out of the ground and push those off in a different direction. So it, in many cases, started out being called pure base, meaning that the base stock was pure and that it didn't have the contaminants in it of regular oil. Now, when this oil is brought back together, all of the pure lubricating hydrocarbons, before they liquefy them again, this is the part that's where it gets the term hydro-treating or hydro-cracking. So oil is cracked down to its molecular structure, you separate it, and then you blast that gas with what's called monatomic hydrogen. Big term, sounds cute. All it means is just a hydrogen molecule is sent into the mix of the gas. Now you might ask yourself, what in the world are they doing that for? Well, in all these hydrocarbons, when they come back together in their natural state, they're going to have what they call polarity, meaning that there are going to be sites within this structure that show a positive polarity. Now, remember for just a minute, all the way back to high school, wherever, that oxygen that floats around out here is a very reactive element, and that's because it has a -2 polarity. So if I make this product that has a positive site on it and I expose it to oxygen, what's going to happen? Oxygen is very reactive. It's going for every one of those exchange sites and latching onto those hydrocarbons. When it does, it produces this stuff that we're all familiar with called sludge. Sludge is oxygen reacting, oxygenated, however you want to call it. The oxygen has reacted with the hydrocarbon chain and it changes its structure into what we call sludge. So we don't want that. So by bringing the hydrogen in, which has a -1 charge, the hydrogen can fill all of those positive sites, and it's called depolarizing the oil. Now that's why it's called hydrotreated. It goes from a petroleum-based stock, it's gasified, it's hydrotreated, it's reliquefied by condensation, and out it goes. Good product, good product. Now contrast that to the original synthetics in the marketplace, which were chemical-based, meaning that they are made much in the same way that we make plastic. And I just use that term loosely because these are synthetic hydrocarbon chains. They are synthesized by the chemists that make them, and instead of turning them into bottles of plastic, we make them into liquids we call polyalpha olefins or esters or a whole bunch of other things. So the idea is that I've got on one hand a very pure, very well made, super refined, high viscosity index product called group 3 hydrocracked synthetic. On the other hand, I have these very unique, tailored, engineered molecules made by chemists that have fancy names like polyalpha olefins and esters. The point is that both these products have a place in the marketplace, but we should never confuse that the group 3 hydrocracked would be as good as the group 4 PAOs or group 5 esters. They just aren't there. It's like comparing the very best bias ply tire you ever bought to a high performance radio. They're just made different. Doesn't mean they won't do some work for you one way or the other. So